March 2023, Pinjore, Haryana, a holding facility at the edge of the Shivalik Hills, and 14 white-rumped vultures standing inside steel release crates, each bird carrying roughly 5 kilograms of muscle and hollow bone, each one representing a debt that an entire subcontinent had been quietly accumulating for 2 decades. The Jatayu Conservation Breeding Center had held these birds through careful, painstaking cycles of captive breeding. Years of controlled feeding, health monitoring, and genetic management, all building toward a single morning when the crate doors would open and the birds would step back into a landscape that had forgotten what they smelled like. To understand why those 14 birds mattered, you need to stand inside the collapse that made them necessary. Through the late 1990s, diclofenac, a cheap veterinary painkiller given to cattle, began moving through the food chain, and by 2008 it had reduced India's vulture population by 99%. I am Dr. Raymond Finch. I spent 40 years documenting ecosystems in collapse and in recovery, and I want you to hold that number for a moment. 99% in under a decade, the fastest large bird population crash ever recorded in scientific literature. And it happened to the species that was quietly running the subcontinent's disease sanitation system. Now, think about what that means for a moment. A single bird can strip a cattle carcass to clean bone in under 4 hours, neutralizing anthrax, botulism, and rabies in the process. Pathogens that, left in open tissue under a 40-degree sun, become community-level threats within 48 hours. Dr. Vibhu Prakash, principal scientist at the Bombay Natural History Society and the researcher who first documented the diclofenac collapse in the late 1990s, stood at the Pinjore release site on that March morning, expecting the birds to spend their first week in territorial orientation, learning the thermals, reading the ridgelines, establishing range. The first bird located a cattle carcass within 6 hours of release. Prakash would later describe that single observation as the most important thing he had witnessed across 30 years of fieldwork. Not because it was dramatic, but because of what it meant for the disease arithmetic that followed in the weeks ahead. Here is where it gets interesting, because you are probably wondering whether 14 birds could actually move a measurable needle on disease rates across an entire region, and whether those early weeks produced numbers precise enough to trust. That answer is coming, and it is worth staying for. What those 14 birds revealed in the weeks that followed their release is that the landscape had not degraded beyond repair. It had been suspended, held in a kind of ecological arrest, waiting for the single missing mechanism to be returned. This is not a conservation story, it is a physics lesson, and the first domino had already fallen. The domino had fallen, but here is what nobody outside the monitoring teams understood yet. The landscape it fell into had been quietly unraveling for more than a decade, wearing a mask of normalcy so convincing that even the people living inside it could not see the damage accumulating beneath the surface. Rural India in 2005 looked, from any road or rooftop, exactly as it always had. Livestock moving at dusk, rivers carrying their familiar load, the sky holding its usual scattered shapes of wings. What you could not see from the road was what was missing from the sky, the wide tilting silhouettes that had kept the land beneath them biologically clean for millennia. Between 1992 and 2007, India lost an estimated 99% of its white-rumped vulture population. Now, a disappearance so rapid that the scientific community's first hypothesis was a novel pathogen, something airborne and aggressive, moving faster than any known wildlife disease. The actual cause was a veterinary painkiller, diclofenac, cheap and widely available, prescribed to working livestock across the subcontinent. It cost almost nothing per dose. It caused fatal kidney failure in any scavenging raptor that consumed a treated carcass within days of medication. The mechanism was invisible, the damage was not. This is the part that made me stop and reread the field notes. Dr. Vibhu Prakash, principal scientist at the Bombay Natural History Society, had spent years mapping what the absence looked like on the ground, and the geographic picture that emerged across 4 survey regions was not a gradual fade. It was a near total erasure, documented location by location, season by season, with the precision of a pathology report. In Rajasthan, traditional roosting colonies that had once drawn thousands of individuals per survey count had fallen to fewer than 12 confirmed sightings across entire districts. Across Uttar Pradesh, congregation sites where 200 or more individuals had gathered daily at livestock carcasses went silent within a single decade, and feral dog counts at those same locations rose by a documented sevenfold. In Punjab, monitoring teams recorded 0 confirmed breeding pairs by 2004. A colony that had produced clutches reliably every season within living memory simply stopped. Along the Gangetic Plain in Bihar, transect surveys that had historically returned 40 to 60 confirmed observations per kilometer recorded 0 sightings across 3 consecutive field seasons. Not a reduction, not a decline. 0, 0. That word appears 3 times in Prakash's survey records across those regions. And each time it does, it carries a specific physical consequence. A carcass left unprocessed, a pathogen left to replicate, a feral dog population left without biological competition for that resource. An estimated 40 million livestock carcasses per year had previously been processed by the most efficient biological sanitation system the subcontinent had ever produced. Stripped to clean bone in hours, pathogens neutralized by stomach acid so corrosive it eliminates anthrax and botulism on contact. That system was now gone, and feral dog populations across India swelled by tens of millions of animals across the following years. Those dogs became the primary transmission vector for an estimated 20,000 human rabies fatalities annually. A figure that epidemiologists, when they mapped it against the documented raptor decline, found tracked the collapse with a correlation no management model had predicted or prepared for. You are probably asking at this point how those 14 individuals released at Pinjore in March 2023 could have produced a measurable shift in disease rates across a landscape this deeply compromised, and whether the epidemiological data from the weeks that followed was precise enough to trust. That question has a specific documented answer, and it involves a mechanism inside the carcass processing chain that the monitoring teams had not anticipated. Stay with this. The most dangerous collapse, Prakash wrote in his 2007 field summary, is not the one that announces itself. It is the one that looks, from any casual vantage point, like continuity. The sky still had wings in it. The land still had scavengers. What changed was the speed, the acid, and the 30 years of accumulated biological memory those wings carried with them. So, the mechanism was identified, the collapse was mapped, and the pharmaceutical cause was sitting in plain sight by 2003. What followed was not a rescue. It was a decade of expensive, well-intentioned motion that changed almost nothing. Dr. Vibhu Prakash, principal scientist at the Bombay Natural History Society, stood in front of committees, presented mortality data, and made the case as plainly as the evidence allowed. The institutional response was a commercially reasonable objection dressed as concern for farmers. Diclofenac was cheap, it worked, and pulling it would hurt rural livelihoods. That objection held for 4 full years, from 2003 to the veterinary ban in 2006. 4 years of continued diclofenac sales, while every monitored breeding colony in the subcontinent contracted further, and the feral dog arithmetic kept compounding in the background. And when the ban finally came, it arrived half-enforced. Meloxicam, equally cheap, equally effective, and safe for scavenging birds, was available the entire time, yet follow-up monitoring teams found illegal diclofenac residues in carcasses at surveyed sites as recently as 2011, 5 years after the prohibition. Here is where the data stops being data and becomes something else entirely. Between 2001 and 2015, Indian public health authorities committed the equivalent of hundreds of millions of dollars to rabies vaccination drives, municipal dog culling programs, and carcass disposal infrastructure. Every rupee aimed at symptoms, none of it touching the source. The feral dog count did not meaningfully fall, the rabies mortality rate did not meaningfully fall, the money moved through the system, produced reports, and the vacancy at the top of the carcass processing chain stayed exactly as empty as it had been the day the last colony went silent. The breeding arithmetic told the cruelest part of the story. A bonded vulture pair raises 1 chick per year, a single offspring, demanding, slow, irreplaceable. A pair of feral dogs produces 2 litters annually, each carrying 6 to 8 pups. The gap between those two numbers is where a decade of policy ran aground. You can already feel the question forming. If 14 birds against tens of millions of feral dogs sounds like an impossible ratio, you are right to press on it. That exact doubt is what the 2023 release data resolves. And the answer is not about the number of birds. Stay close, because the mechanism is more specific than anyone expected. Prakash had spent 22 years building toward the March 2023 release at Pinjore. He anticipated a week of territorial orientation before the birds began feeding independently. The first bird located a cattle carcass within 6 hours of release. And Prakash said with characteristic restraint that it was the most important thing he had witnessed in 30 years of work. 14 birds, no salary, no hygiene protocol, no management plan. They stripped their first carcass in under 4 hours, and they did it for free. The bird, it turned out, had been carrying the weight the entire time. We had just spent a decade refusing to put it back down. What happened next was not a recovery story. It was a sequence, precise, measurable, and brutal in its efficiency. And it began the moment those wings caught the first thermal rising off the Haryana plain. A white-rumped vulture does not search randomly. It reads the sky, watching the descent angles of every other bird within kilometers, triangulating, correcting, and it arrives at a carcass site with a precision that no drone, no sensor array, and no municipal hygiene vehicle has ever matched. A group of 6 to 10 birds reduces a cattle carcass, weighing 250 kilograms to clean bone in under 3 hours. Not because they are efficient by accident, but because 40 million years of selection pressure built them to be the fastest, most chemically complete sanitation system the land has ever produced. That physical act, flesh becoming bone, is a chemical event. The stomach acid of a vulture holds a pH of roughly 1, among the most corrosive digestive environments of any vertebrate alive, and it annihilates anthrax spores, botulinum toxin, and rabies virus that an open carcass would otherwise amplify across 3 to 5 exposed days. Think of it as 3 interlocking events happening simultaneously. The carcass disappears, the congregation point vanishes with it, and the feral dog density in that immediate zone begins to fall within days, pulling the bite rate that drives rabies transmission down along with it. Dr. Vibhu Prakash, monitoring the released cohort across Haryana through 2023, documented the first measurable epidemiological shift within weeks of the March release, not months, weeks, as the 14 birds established feeding circuits spanning a radius of roughly 100 kilometers from Pinjore. 14 birds, 100 kilometers of active corridor. The public health researchers consulting on that project had to go back and rebuild their transmission models from the ground up. You are probably asking yourself the question that every field ecologist eventually asks: if 14 animals could shift measurable disease pressure in weeks, why did it take the better part of 2 decades to put them back? The answer is coming, and you will want to stay with it, because it is not the answer any institution has been comfortable writing down. Remove a carcass in 3 hours instead of 5 days. You subtract 5 days of pathogen amplification from the surrounding environment. Multiply that across the 30-year lifespan of a single bird, and the sanitation arithmetic becomes something no infrastructure budget has ever honestly confronted. The chain reaction is not metaphor, it is physics, verified, documented, and now sitting in the field reports of the Bombay Natural History Society, waiting for the policy conversation that has not yet caught up to what those 14 animals quietly proved. And now the part that made me stop and reread the field notes. Not once, but 3 separate times before I trusted what I was looking at. The breeding program models had been careful, conservative, almost elegant in their projected boundaries. Released individuals were expected to hold a monitored corridor, returning to familiar roost trees, feeding at known sites. The program managers had staked the first season's credibility on that assumption. The satellite tags told a completely different story. Tagged individuals from the Pinjore cohort were recorded moving well beyond the projected 100-kilometer radius inside a single season. crossing state lines into zones where no carcass monitoring infrastructure existed and no veterinary coordination had been established. One tagged individual was recovered having roosted on a temple roof in a village community that had never been briefed on the reintroduction program, and responded, understandably, with alarm, not hostility born of malice. Alarm born of ignorance the program had not anticipated funding its way out of. Farmers along the release corridors reported the same animals landing on thatched roof structures, investigating stored livestock offal. Not a health threat by any veterinary measure, but a cultural friction that required community liaison work the program budget had not honestly anticipated. Dr. Vibhu Prakash logged the most complicated tension in his 2023 field notes, a cascade nobody had modeled. In at least 2 documented zones, feral dogs displaced from feeding sites shifted their ranging behavior, moving closer to village perimeters at night and temporarily increasing human-dog contact after dusk, the precise opposite of the intended outcome. You are probably forming a question right now, whether a recovery this ungovernable could undermine its own goals before the sanitation gains had time to consolidate. That answer is in the long-term monitoring data, and it is worth staying with this story to see how it resolves. The recovery was working. It was also faster, messier, and more geographically ungovernable than any single stakeholder had modeled. That is not a failure. That is what returning a living engineer to a living system actually looks like. A recovered species does not restore itself inside your boundaries. It restores the landscape according to its own logic. And the landscape's logic is always larger, always older, and always less polite than the plan. And if 14 animals could do this, rewrite dog behavior, cross state lines, alarm a temple village, and still reduce pathogen load faster than any infrastructure the government had funded, the question waiting in the next chapter is what happens when you scale that number by a factor of 10. So, if 14 birds could rewrite the equation that badly, what does it mean that for at least 6,000 years, across every district of this subcontinent, millions of them were doing exactly that work, silently, every single day, and nobody counted the epidemics that never happened? That is the number that should stop you, not 14. Not the weeks it took for pathogen load to shift. The real number is 6,000. Years of invisible public health infrastructure that had no name because it had no absence to measure it against. And then one cheap veterinary drug entered the livestock supply in the early 1990s. And within 10 years, that entire system, 6,000 years of biological sanitation, was functionally erased. Dr. Vibhu Prakash, principal scientist at the Bombay Natural History Society, spent 30 years measuring what the collapse cost in biological terms. By the time the ban on diclofenac was enacted in 2006, India had lost an estimated 99% of its vulture population, a decline with no modern parallel in any vertebrate species on the subcontinent. What replaced them was not nothing: feral dogs. And the feral dog population across rural India expanded to fill every ecological vacuum the vultures left open, carrying rabies into communities that had never needed to worry about it at that scale. The arithmetic of that substitution is stark. A vulture eliminates pathogens at a carcass in under 3 hours. A feral dog prolongs exposure across 3 days. Long enough for anthrax spores to aerosolize, for botulinum toxin to leach into soil, for a rabies vector to bite and move on. When Prakash stood at the Pinjore release site in March 2023 and watched the first bird locate a cattle carcass within 6 hours, not in a week, not after territorial settling, but within 6 hours. What he was watching was a system remembering itself. The bird did not need retraining. The landscape did not need instruction. The biology simply resumed. A system does not forget its own equilibrium. You only have to stop poisoning it. Drop your region, and the name of one species you have personally watched disappear from your landscape in your lifetime in the comments below. Because that absence has a cost the biology is already calculating, whether anyone is measuring it yet or not. And yes or no in the comments, have you ever seen something come back that you were certain was gone for good? Because if the answer is yes, I want to hear that story. Share this with someone who still believes the damage is permanent, because the evidence says otherwise. In the next video, I am taking you to the Scottish Highlands, where 6 white-tailed eagles reintroduced to a single loch triggered a documented 40% increase in riparian vegetation density within 8 years, a result that stunned every monitoring team that saw it. Scottish Natural Heritage formally resisted the reintroduction until 1975, citing livestock predation risk, and the sheep mortality figures they cited in opposition were later contradicted by the recovery data's own verified counts. The tension no one has yet resolved is whether a landscape has the right to recover when the people living inside it never consented to the animal's return. I'm Dr. Raymond Finch. I'll see you in the field.